This video is sponsored by Dev Mountain. If you're interested in learning web development, iOS, or UX design, Dev Mountain is a 12-week design and development bootcamp intended to get you a full-time position in the industry. To learn more, visit devmountain.com or click the link in the description below. Hey, what's going on, guys? Welcome to my MySQL crash course. So in this course, we're going to be going over things like managing users, writing SQL queries. Database administration can get pretty intricate, but as far as writing queries to select data, insert, update, delete, all that stuff, we're going to go over that pretty well as things like primary keys, foreign keys, joining tables together, aggregate functions, and more. Okay, I'm going to have a link in the description to a gist with all the queries that we're going to write. So if you want to follow along, but you don't feel like typing everything out, you can copy and paste from that. You can also use it as a reference in the future. Now, I just want to go over some slides before we jump in. Let's talk a little bit about what MySQL is, or MySQL. Some people pronounce it MySQL. It's a very popular open source relational database management system. There's different types of databases or database management systems. You have relational, you have NoSQL, you have distributed, graph databases. There's all different types, but relational databases are very popular within web development, with which, if you're watching my channel, you're probably interested in. So some other examples are Postgres, Microsoft SQL Server, Oracle database. These are all relational. And one thing that relational databases have in common is they all, as far as I know, all of them use SQL, which is structured query language. And SQL, for the most part, is it's just that. It's a query language to do things like select data, insert, sort, all that stuff. And it's very similar across all relational databases. It's not identical. There are some quirks in the syntax depending on which relational database you're using, but a lot of it is the same. So if you learn MySQL, chances are you're going to learn, let's take Microsoft SQL Server, for example. You'll be able to learn that very quickly. You'll just have to learn some of the different differences in the syntax. All right, MySQL is a leading database for web applications. It's used in small business websites all the way to very large-scale enterprise applications. So you can use it for just about anything. It's used with multiple languages, pretty much any programming language, but it's very popular with web-based languages or languages that are used highly in web development, like PHP, Node.js, which is JavaScript, Python, C#, languages like that. It's completely cross-platform, so you can install it on Linux, which is probably what you're going to use in production, but you can also install it on your Windows or Mac. I'll be using it on a Mac, but I'll also talk a little bit about some of the steps you need to take for Windows. All right, so a relational database is based on the relational model of data. And like I said, virtually all relational databases use SQL to manage them, and they use something called tables to store your data, and these tables have columns and rows, similar to what you'd see in like an Excel spreadsheet, just much more powerful. And tables and fields can relate to each other through something called keys, which I'll show you an example of in a minute, and we'll also be doing this later on through SQL. So here's an example of a very simple table that I created. So this would be like a users table for a website, and we have an ID, first name, last name, email, and password. So what you see here going down vertically, these are columns. Okay, so we have columns that have a specific field, such as ID, first name, and so on. And then we have these rows of data that are inserted. So we have this John Doe user, Sarah Watson. So these are rows. Now, each field has to have a certain data type, okay? And there's a lot of different data types. I'm not going to go over all of them, but some of the common ones I have listed down here. So for numeric, we have an int, which is an integer. I believe an int can be from anywhere from -2 billion to 2 billion. As far as I know, something like that. We have tiny int, which is a tiny number, usually used for Boolean because there's not an actual Boolean data type in MySQL. So a lot of times we'll use either 1 for true and 0 for false, and that will be a tiny int field. We also have big int for really, really big numbers. We have floats for floating point numbers. For strings, we have varchar, which is a variable character, commonly used for things like names and emails. They actually have a max of 255 characters. We also have a text field for larger things like blog posts. And then for really large text, if you want more than like, I think it's 65,000 characters is the limit for text, we have long text. All right, so we have a bunch of different text fields or string fields. For dates, we have date time, we have timestamp, and then we have others like binary, JSON. There's a lot of different data types, and if you want to look into some of the more rare ones, you can go ahead and look at the documentation. But this course is very practical, so we'll be using things that you're going to come across quite a bit. All right, now it's a relational database because you can relate data to each other. So here's an example of maybe an e-commerce site database where you have certain fields. For instance, we have users, okay, and then we have orders, we have order items, products, merchants, countries, and you can see that there's relationships between these tables. And in the users table, we have an ID. Now, in relational databases, you have something called a primary key, which is basically the unique identifier or key in your table. So you don't want to use something like name for your primary key because there might be more than one user with the same name. So the ID is always going to be unique. And what we can do is create another table, such as orders, and create what's called a foreign key. Okay, so in this case, we have user underscore ID, and then that user underscore ID will be linked to the primary key of the users table. So that way we can create a relationship between those two tables, because we might want to make a query where we get, let's say, the full name, the email, and maybe the order status. Okay, or the order ID or something like that. So we can actually do what's called a table join, and we can query data from multiple tables, and it can be more than two. You can do 3, 4, whatever different tables, and you can combine that data. All right, so I'll show you how to do that in a little bit. All right, so let's talk a little bit about getting set up and installation. So locally, you can install a standalone server of MySQL. This is what I'll be running on my Mac. But you can also install software suites like XAMPP or MAMP, which they come with an Apache web server, PHP, which is a programming language, MySQL, and some other stuff as well. So you might want to look into that. And then you also have the option of using Docker or something like Docker where you can use virtualization. So for instance, you can create a Docker container with MySQL running inside of it, which is much more advanced and beyond this tutorial and not something I would suggest if you're just starting out with this stuff. Now, as far as production, it really depends on what hosting solution you're using. If you're using something like, let's say, HostGator or Bluehost or something, those services offer cPanel, and they actually have MySQL pre-installed. So all you have to do is go into cPanel and create a database, and you can do it all graphically. All right, if you're using a solution like, let's say, DigitalOcean, which is cloud hosting, they pretty much just give you a terminal or give you a Linux container and you access it through a terminal. In that case, you would install MySQL using whatever package manager that Linux distribution uses. All right, so production, it varies depending on what you're using as far as a hosting solution. But in this video, we're mostly focusing on SQL itself within MySQL, so we'll be dealing with a local server. All right, now as far as managing your server or managing your databases, there's different ways to do this. So with MySQL, you get a shell program that you log into through a terminal or command line. We're going to be working with that at first. You should definitely know how to log in and how to make simple queries and stuff like that. You also have desktop tools such as MySQL Workbench, which I'm actually going to switch to about halfway through just to give you an example of a different tool. You also have web-based tools. In fact, if you install XAMPP, and I believe WAMP and MAMP also come with a tool called phpMyAdmin, where you can log into the program through your browser, your web browser, and you can actually manage your database from there in a graphical interface. All right, so enough talk, guys. Let's go ahead and jump in and let's get started with MySQL. All right, guys, so we're going to get started now. Before we jump into MySQL, I want to go over the download and installation. I already have it installed, but just in case you don't, if you want to get the standalone version, you can go to mysql.com/downloads, and it doesn't matter if you're on Windows or Mac, and you want to go down past this commercial enterprise version down to the community edition and click on this link here. Now from here, you're going to want to download the community server. So if you click download here, It'll take you to a page like this. It already pre-selects Mac for me because I'm on a Mac, and you want to download this DMG archive. So just click download here. Once you do that, just double click on the icon, go through the steps, click next. It'll ask you to put in your root password because you're going to have a user with the name of root, and you need to add a password for that user. All right, if you're on Windows, same thing. It'll just choose Windows here. And you can download either the zip here or click this button and go to this page and download the MSI installer. So it'll be just a graphical installer, same idea. Click next, add your root password, and you should be all set. Now, we're also going to be using a tool called MySQL Workbench. So if I go back to downloads, back to community downloads, you'll see MySQL Workbench right here. So if I click download, I can just go ahead and download and install that. And same thing, just click next and it'll set it up on your system. Okay, so that's how you can download and install MySQL. Now, if you want to use something like XAMPP, you can do that. This comes with Apache. MariaDB is basically like a superset of MySQL. So it has everything MySQL has plus some other stuff, or a drop-in, whatever you want to call it. So you can use this if you want. There's other suites like this, for instance, MAMP, WAMP, and I believe all those come with MySQL as well. So it's up to you on what you want to use. Now, once you get MySQL installed, you're going to need to know the path where it's located on your machine. Now, I have a cheat sheet just here, and I have the link to this in the description. And if you're on a Mac, it's going to be in, if you install the standalone version, it'll be in the USR local MySQL/bin. Okay, that's where the actual MySQL binary is going to be. If you're on Windows, it'll most likely be in Program Files, MySQL, whatever the version is, and then bin. And then if you're using XAMPP, MySQL will actually be in the XAMPP folder. Okay, if you're using Linux, it depends on the distro you're using. So you need to find the path to MySQL. Now, once I go into my terminal here, if I do MySQL -- version, it works for me, but if you just installed it, it's probably going to say command not found, and that's because you don't have the MySQL command in your path. All right, if you go to the actual bin folder and you run it, it should work. However, you probably want it so you can run it from anywhere on your machine. Now, for Mac, I have it right here in the gist. You can do one of two things. You can run this command, which will add it to your current session so that you can use the MySQL command now, but if you close the terminal and come back, it won't work. If you want to add it permanently, you need to just add it to this .bash profile, this hidden file right here. So you could actually copy this command and just go ahead and paste that in here and run that. All right, I'm not going to run it because I actually already have it there. In fact, I'll show you if I do a cat command, which will just preview a file, and I'll do bash_profile, you can see that I have my MySQL path right here. So it'll just add it to that file. Now, if you're on Windows, it's a little different. I have a link right here that you can go to that will kind of tell you what to do. You just need to go to Properties, Advanced Environment Variables, System Variables, and then Path. Click Edit, and then add your path, which will look something like this. Make sure that it's the correct file, correct path with the correct version here. All right, and then you should be able to access the MySQL command from anywhere. So once you do that, once you have it installed, you have your path set up, you can go ahead and log in right in the terminal, okay, right in the shell. So we'll do MySQL -u for a username. We're going to use the root user, and then -p to let it know that we have a password for this user to put in. Okay, then it will ask for the password. You want to put your root user's password, not your system, not your Mac or Windows password, and then you should get logged in. All right, I'm just going to minimize that. And you can tell we're logged in because of all this stuff and because we now see MySQL in the prompt right here. So we can clear this with Control L. And what I'm going to do is I'm going to do a few things within the shell here just to kind of show you how it works. And then I'm going to jump into MySQL Workbench because it's a lot easier to read, it's a lot easier to write in, and I think it'll just be a better experience than working in the shell. But from here, what I do want to do is create a new user, because right now we're logged in as root, and when you create a new database for a new application, you probably want to have a specific user for that database. So we can say create user, and inside quotes, I'm going to use Brad as my username, but you could use whatever. And then we want to do at, and then another set of quotes, localhost. Okay, now we want to add a password to this user, so I'm going to say identified by, and then a password, and then a semicolon. So I'll just do 1 through 6. Okay, so just doing that will create a new user for us. Now, take note of the convention where I use these caps for create user and identified by. If we go back to the cheat sheet, which is right here, you notice that it's just a common convention throughout all the queries here. Drop user, create database, drop database, create table. It's all caps. Even when we do the selects, the from and the where, it's just the common convention for SQL. So you want to get comfortable with that type of syntax or that type of convention. You don't have to do it. I mean, it will still work if you do all lowercase, but it's a lot more readable, and it just, you can see exactly what's going on. You're selecting something from something. All right, so I'll be using that syntax. So let's jump back in here and close that up. Now, if we want to see the users that we have, we can actually do a select. So we can select user. We could also select host, from, and then MySQL.user semicolon. And that will show us our users. We have our root user, Brad, and then these system things here, which we don't need to care about. All right, now I'm going to clear this up. And I want to give this user some privileges because right now they can't really do anything. I want to basically make the Brad user an admin so he can create new databases, update data in other databases, stuff like that. So full access. And you can go to the documentation if you want to see like the specific privileges you can add. I'm just granting all privileges. So I'm going to say grant all privileges on, and I'm going to do asterisk dot asterisk and then 2, and then the user I want, which is going to be Brad at localhost and semicolon. All right, so this will grant all privileges, and once you do this, you want to actually flush privileges, which will clear the grants table. So we want to do flush privileges like that. All right, and if we want to check the privileges for a certain user, we can do show grants for, and then the user. So say Brad at localhost, and now you can see all the stuff that user can do. Okay, so I'm going to clear this up, and then we can actually exit out of MySQL. So I'll just do exit. And that takes us back out to the terminal here, the command prompt. And I'm going to log back in as Brad. So instead of using root here, I'm just going to use Brad and enter that password. And now I'm logged in as that user. So you can switch users just like that. So let's create a database. I'm going to go ahead and say create database, and I'm going to call it Acme. So now if you don't put a semicolon, it'll go on to the next line like that because you can do multi-line statements. So just put a semicolon if you forget, and it'll run it. All right, now if we want to show our databases, we can simply run show databases. And now you can see we have that Acme database. Now, in order to use that database, we actually have to specify use and then the database name. So we'll say use Acme. Okay, and it says database changed. So we'll clear that up. Now I'm going to jump into Workbench pretty soon, but I just want to do just a create here just to add a table, because right now there's no tables. In fact, we can say show tables and we get empty set. Okay, so I'm going to go ahead and do a create table. I'm going to call it users, and I'm going to do a multi-line statement just so it's more readable. So I'm going to open up parentheses and hit enter. And then in here, we want to start to put our fields. So I want an ID, which is going to be an int, an integer, and I want it to be auto increment. So auto underscore increment and comma. Now what auto increment means is I want it so that the ID is going to be unique and it's going to get added automatically, and it's going to increment automatically. So the first user we insert will be ID 1, next one will be 2, next one will be 3, and so on. And it'll keep incrementing. All right, that way we don't have to even worry about inserting an ID. So that's our ID. Let's do a first name. Now, I like to use underscores to separate the words in my fields, but you could do like that, or even like that. But usually in relational databases, I'll do it this way. And then this is going to be a varchar, which will be, let's do 100 in length. Now the max for a varchar is 255, just to let you know. And some people will always put 255. I like to keep it at a reasonable. I think 100 is good for a first name. And then let's do last name. So we'll do 100 for the last name. Let's do email. We'll do 75. Okay, password. Now passwords are usually, or should always be, hashed or encrypted. So they could be very, very long. So I'm going to do 255. Okay, let's do location. Let's say 100, and let's do a department. Do say 75. Let's do an is admin. Let's say that this application we're building, you can have admin users. This is going to be a tiny int, which is used as a Boolean, and it's going to be just one character. So we want it to either be a 1 or a 0. 1 if it's an admin, 0 if not. And then let's do a register date, which I'm going to make a date time field. Okay, now the last thing I want is to specify a primary key, and that's going to be the ID. So we want to say primary key, and then in parentheses whatever field we want, which is going to be the ID. All right, and then last thing is just to close everything and put a semicolon, and we'll run that. We get query OK. Good. So now we can actually do show tables, and you can see that we have one table. We have users. Okay, it's completely empty. We don't have any actual users, but we have the table there. And just to let you know, if you wanted to get rid of a table, you could just do drop table and then whatever the table name. So you could do that. Also, if you wanted to delete a whole database, you could do drop database and then Acme. So we could run that as well. All right, but what I'm going to do now is just exit from this. Oops, I spelled that wrong. So we'll exit from that, and I'm going to actually open up MySQL Workbench. All right, now once you open Workbench, you should automatically see your local instance, and by default, MySQL is going to run on port 3306. And you can see it's going to be the root user, but if you want to log in as a different user, such as the Brad user I created, I could say edit connection, and I could just change this to Brad, and then it will prompt me for that password. But I'm just going to log in as root here, so I'm going to double click, and it's going to ask me for the root password. Okay, so it's going to take us to a screen like this, and there's a lot to Workbench. I'm not going over like the actual platform. I'm just using it to make our queries more clear and the results and stuff like that. But this is a query window, so we can write queries in here just like we were doing in the terminal. If we go over here to the side and we hit schemas, you'll see that we have our Acme database. Okay, in Workbench they're called schemas, and if I hit the arrow here and go under tables, we'll see the users table. If I go under columns, we'll see all the columns that we created. All right, so what we need to do is we actually need to select a database or a schema to use. So we're going to choose, right click here, and we're going to say set as default schema. Okay, now we don't have any data in here yet, so I want to add some, but just to show you, we can do a simple select. So I'll select all from users. Now to run this, we can either hit this lightning bolt, So that'll run it, or we can do control enter or control return, and that will also run it. So that's what I'll be doing. And you can see that nothing comes up. We see basically an empty table. We have all of our keys here. And I apologize that these are small. I couldn't figure out how to make this font size bigger. The results, though, do have a bigger font size, so you will be able to see that. And then down here, you'll see the action output. So these green check marks means that it went through okay, there's no errors. If something happens, if something goes wrong, then it'll give us a message like, let's say, I don't know, from ABC, and run that. Then we get an error, and it just gives us an error code that says ABC table name doesn't exist. All right, so it gives you a little log down here. So let's clear that up, and let's insert a record or a row. So we already have the Acme database or schema selected, so I'm going to do insert into users, and then in here we want to put the fields we want to add. So basically everything except the ID, because the ID is auto increment, so we don't need to add that. So we want first name, last name, email, password, location, department, is admin, and register date. So we want those fields added. So I'm going to go after this parentheses here, and I'm going to go ahead, I'll just go on the next line and say values, and then another set of parentheses with our values. Now if you're putting in a string, actually I'm not going to use my name, let's do John. You want to put quotes around it, okay? So John for the first name, Doe, and make sure that this order is the same as this order. So John Doe, next is email, so we'll say john@gmail.com. Password, I'm just going to do 1 through 6, although you always want your passwords encrypted. If you're building a web app or anything like that, if it's a password, you want it to be hashed and encrypted and secure. You never want to put plain text in a database for a password. So location, I'm going to say Massachusetts. Department, let's do development, is admin, we'll put a 1. And then register date, we could put a date string here if we wanted to, but I'm actually going to put in now with some parentheses, which is a function that will put in the current date and time. Okay, so that should work. Let's run it with control enter, and we get a green check down here. I know this is small, sorry about that, but it says that it was inserted, 1 row is affected. And now let's do a select all from users. We'll run that, and we get our result. Okay, and it's nicely formatted. Now you can save tabs with queries, so you can save them. You can have as many tabs as you want. I'm just going to be working in the same tab just to make it easy. But if you want to save like long, difficult queries, you can do that. There's a lot you can do in this platform. I might do a tutorial on it actually. But let's go ahead now and let's add some more data to work with. Now I'm going to show you how to add multiple records, but I'm not going to type it all in just because it's so much. So if we go to the cheat sheet here where it says insert multiple rows, I'm going to grab this, and this will insert 5 more users. So if I copy that, go back in, paste that in. It's just the same thing, insert into users and then all the keys, and then we can just have multiple values. So we have values with our parentheses, we have 1 user and then a comma, and then another set of parentheses with another user, comma, another set of parentheses. So we have just a bunch of users. Okay, so you don't have to do like 5 different inserts if you want to insert 5 users or 5 records. So we'll go ahead and run that. And we get a green check. So now let's do a select. You could also do this. You can right click users and say select rows, and it'll show you them as well. All right, so you can do that, and you can see now we have a bunch of users here that we can deal with, and they all have different locations. Some are the same thing with the departments, so we can kind of search by that. Passwords are all 1 through 6. So let's look at selecting some more. So we know how to select all. If we want to select just the first name, let's say first name, last name, We don't need acme.users since we selected that database. So that will just give us just the first and last name. Now, let's say we want to get, let's do select all from users, and I want to specify a where clause. Okay, so this is called a where clause. We want to basically narrow it down, and I'm going to narrow it down to where their location is equal to Massachusetts. Okay, so if I go ahead and run that, notice it only gives me back 3 results. Okay, 3 out of the 6 users, and it's only the users that are from Massachusetts. Okay, now if I wanted to get the users that were just from Massachusetts, but also only in sales, I could put multiple conditions here. So I can say and, I'll say and where sales is equal to, not sales equal to, department. Department is equal to sales. Okay, if I run that, now we get only the users that are from Massachusetts and that are in sales. Now we can also use operators like greater than and less than. So let's see. So with what we have to work with, let's say select users where is admin is greater than 0. So if we run that, we'll get any is admin that's greater than 0. Obviously we only have 1, so that's what's going to show up, but we can use greater than, less than, greater than or equal to, less than or equal to, and so on. Now I'm going to get back to some more stuff we can do with select, like concatenating and using like and stuff like that, but I want to show you how to delete and update data as well before we get into that. So let's clear this up, and let's say we want to delete a row. So we have 6 users, 1 through 6. Let's do delete from users. Now, it's really, really important when you do an update or a delete that you make sure you add the where clause, because you can end up deleting all your records, or you can end up updating all your records. So make sure you do that. So we're going to say where, and for the most part, you're probably going to use your primary key, your ID. So we'll say where ID equals 6. So I'll go ahead and run that. We get a green check. So let's do a select. Actually, I'll just say select rows. And now you can see that the user with the ID of 6 is now gone. So let's update a user. Let's say Fred here wants his email updated to, let's say, freddy@gmail.com. So we can say update. We'll say update and then the name of the table, so users, and we want to say set, and then the field we want to set, so email. Let's set email to freddy@gmail.com. And this, again, very important to put the where clause, otherwise all of our users are going to get their email set to freddy@gmail. So it's very important to have that where clause. So we'll say where ID equals 2, because that is the Fred user. So we'll run that and select our rows again, and now you can see that his email has been updated. Okay, so basic CRUD, create, read, update, and delete is pretty simple. And again, I have all these queries in the gist in the description, so it's not like you have to remember all this stuff. So let's say we want to add a new column here. Right, so we want to add, let's say, an age. So we can do that with the alter table command. So let's do alter table, and then the name of the table, and then I'm going to say add, and I want to add an age. And we need to set a type for this. So let's say varchar, and let's do 3. Okay, so we'll go ahead and run that. Now if I select my rows, you can see that age has been added and they're all null. Okay, I really haven't talked about null, and null is basically just empty. Okay, it's a field that is just empty, and you can set certain columns so that they're not null, meaning they can't be null. It's not possible, but for the most part, you're going to allow null in columns. All right, so let's say we want to modify a column, like let's change this age from a varchar to an int. So we can say alter table users, and instead of add, I'm going to use modify column. And I believe this is different if you're using like Postgres or something. I think it's like alter column or something like that. But we're going to say modify column age, and we're going to set it to an int of 3. Okay, so now I'll go ahead and run that, and it should just give me the same result, but now the age is an int. Now we can also edit stuff from here, update stuff from here. We don't have to use the query window up here. Oh, I didn't realize it was opening new tabs every time. But let's say we wanted to add ages here. I could just double click. Let's say 20. Go here, 23, and obviously this is just, we're able to do this because we're in MySQL Workbench, but that's what these programs are really good for. Let's say 40. All right, so if we hit apply, that should run that query and change these values. So let's hit apply. Okay, so it's going to ask us to review the SQL script to be applied on the database, and you can see it's just a bunch of updates. It's setting age to 20. And then 23, 34, whatever. So let's apply. Okay, so it looks like that went okay. Now if we run the select again, you can see that the ages are now these numbers here. So we can update stuff right from within the table here. So let's see, we added a new field, we modified it. Let's go back to some of the stuff we can do with select. Now if we want to order things in a certain way, we can use order by. So let's do select all from users, and let's do order by, and let's order by, we'll say last name. Now we can do either ascending or descending, so we can do ASC. And now if we look at our last names, you see that starts Doe is at the top here, Watson is at the bottom, and if we want to do descending, we can do DESC and run that. Now Watson is at the top and Doe is at the bottom. Okay, so pretty simple. Another thing we can do is we can concatenate columns. For instance, we have a first name and a last name field. Let's say that we wanted to create a result where we had, let's say, just name that had first and last name. So we can use concat for that. So we'll say select concat, and inside here we'll do first name, comma, and then I'm going to concat a space here in the middle of the two, and then put the last name. So we're going to select that, and let's also do, well, we have to do an as, and then whatever we want to call this field, or this column, which we'll call name, and then let's also select department. We can select any other fields we want as well. And we'll say from users. So if we run that, we get this one column now called name that has both the first and last name. And we get the department because we added that in there as well. All right, now the next thing I want to show you is if we want to get distinct rows, meaning let's say we only want one user from each location. We want distinct locations. We don't want two results with Massachusetts or two with New York. So we could do select distinct location from users. And it's just going to show us just the locations. Okay, so for some reason you needed in your application to get just the available cities, or just the locations of the users, you could run this query and get them without having them repeat, because if you just say get location, then you're going to get repeat locations, and you might not want that. So that's what distinct is good for. Now we can also select ranges using between. So let's say we want to select all from users. We want to use a where clause here, and we can say where age is between, and we'll do 20 and 25. So if I run that, we get two users, which are 20 and 23. We'll change this to 30. Now we get all users between 20 and 30. Okay, so now we're going to move on to like, and like is used for full text searching. For instance, if you want to search a blog post for a specific word or something like that, that's what this is good for. So I'm going to do select all from users where, and I'm going to say we're a department like. Okay, we want to use the like keyword here, and we want to use a percent sign. So I'm going to say D percent. Now what this means is it's going to match anything that starts with a D. Okay, so any value that's inside of department that starts with a D, this should match. So let's go ahead and run that, and we get development, design, development. So obviously sales doesn't match this query here. And we can make this go further by saying let's do DEV. So obviously, well, let's do DE. So that's going to match development and design, but obviously DEV, if we run that, we're just going to get development. Okay. Now, if we want to search the end of something, we could do %T. So this means just whatever and then ending with a T. So if we go ahead and run that, we're going to get development because it ends with a T. Now, if you want to search, most of the time you're going to have % and then something %. So if you want to search for, %, if you want to search for a word or something, this means that anything could be before and anything could be after it. So we'll do like, I don't know, let's do OP and run that. We're going to get development because there's an OP in development. If we do ES and run that, we're going to get both design and sales because there's an ES in both of those. And it doesn't matter if it's at the beginning, end, or middle because of how we put these % signs. Okay, so hopefully that makes sense. Now at the same time, we can do not like, which will just give us the opposite. So if I run not like ES, we're going to get development because that doesn't match that. Now another thing we can do is we can use in to use lists. So let's say we want to get all the users that are in design and sales. So we'll go ahead and select all from users where, and we're going to say where department in. And then after in, we want to open up some parentheses and we can put in comma separated values of the departments we're looking for. So let's say design, and let's put a comma here, and let's say sales. Okay, so we'll go ahead and run that, and it will give us everyone in design and sales. Now, we could just do where department equals design and department equals sales. That will give us the same result. But imagine if we're searching, 10 different departments. So that gets to be really long and messy, where with the in clause, we can just stick them all inside here in a comma separated value list. So next thing I want to talk about is indexes. So indexes are used on columns and tables to speed up queries and find things more quickly and efficiently. You can almost think of them as an index in a book. Okay, primary keys like our ID are indexed, but we can add custom indexes on other fields as well. And you want to put indexes on fields that you're going to be searching by a lot within whatever it is, your application. Now, if we go to on the side panel here, users, and we look under indexes, we're going to see our primary key as our index. Okay, if we look down here, you can see that it's the column ID, and that's indexed as a primary key. But let's say we have an application where we're going to be searching by the location quite a bit. So adding an index will allow that to be more efficient, just be a faster search. So what I'm going to do is add an index onto the location field. So we can do that by using create index, and then we name it. I'm going to call it L index, so location index. And then we can just do on, and then the table name, which is users, and then inside parentheses, the field that we want to add it to, so location. So if I go ahead and run that, we get a green check down here. And if I go and I reload this, if I click this reload button, you'll see under indexes, we now have the L index. And if we look down here, you'll see that it's the location column. Okay, so when we search by location, it should be more efficient. Now, if you want to remove an index, you can easily do that by doing drop index and then the name of it, which is L index on users. So we'll run that. Okay, if we reload this again, now you can see that that index is gone. So you really want to examine what fields are going to be searched on, what queries are you going to make, and add your indexes based on that. Okay, which can be a science in itself, making a database more efficient. So now what I want to do is start to look at foreign keys. I want to look at relationships between tables. So I'm going to create a new table. Up to this point, we've been working with just the users table. So let's go ahead and I'll just type this out. Let's say create table, and we're going to create a table for posts. All right, and I'm just going to put this on a new line here. So create table post. Let's add an ID, which is an int, and we want to do auto increment. And this stuff will actually pop up in the IntelliSense. It's not uppercase, but that's fine. Let's do user ID underscore ID. Now this is going to be an int, but this is going to be our foreign key. Okay, so what I mean by that is this is going to correspond to the ID field in the users table so that we have a link between posts and users. So let's also add a title for our post, which is going to be a varchar, and title will say 100. And then we're going to want a body. Now the body could be more than 255 characters, so we don't want to use varchar. We want to use text, which I believe has a max of 65,000, something like that. Okay, we'll put a publish date. So publish date, I'm going to use date time, but I also want to introduce you to defaults. Now you can set a default value for a field. So I'm going to do default, and we have, actually let's do uppercase here just to stay consistent. So date time and then default, and there's something called current timestamp that we can use. Okay, now current timestamp is sort of like using the now function, except we're putting it in when the field when it's created, and we don't actually have to add the publish date ourselves. It'll get added automatically. Okay, so we can use a default, and we could use a default of anything, but there's a specific current timestamp that'll give us just that. Now we want to assign a primary key just like we did for our users table, and the primary key is going to be the ID, but we also have a foreign key in this table, which is user ID. So we want to specify foreign key. Let me spell foreign key, and the foreign key we want is user underscore ID, and we have to specify the reference. What is this key reference to in terms of its related table, which is the users table. So we want to add references, and we're going to reference the users table, and the primary key is the ID. Okay, so we're basically linking this to the ID on the users table. So hopefully that makes sense. Let's run this, and now we should have two tables. If I reload this and we look over here under users, where's, oh, right here. So posts, columns, we have all of our columns. Good. So now let's add some data to our post table to work with. So I'm going to actually grab this from the gist that I have, and it's right here. So it's just a create table. Not a create table, I'm sorry, we want this. We want to add the data. It's just an insert. So we're going to insert the user ID, the title, and the body. We don't need to insert the ID, it's auto increment, and the publish date has a default of the current timestamp, so we don't need that either. We just need these three things. So let's go back and paste that in. So it's just going to add, post 1. So this would be the user ID of 1, title, body, user ID of 3, title, body, and so on. So we'll run that. And now we can make a select all from posts. And there we go. We have 10 different posts here, and this number corresponds to the user ID. So now that we have this post table, let's do a join, because if we want to get data from two different tables that are related, we need to do what's called a join. And there's different types of joins. There's inner joins, which will return rows when there's a match in both tables. We have left joins, which will return all rows from the left table, even if there's no matches in the right table. And then a right join, which will return all rows from the right table, even if there's no matches in the left table. And I know that is confusing. It confused the hell out of me when I was first learning it, and it's kind of hard to explain. So you might want to do a little bit of research on it. But I noticed throughout my career, inner joins are what I use the most. So let's go ahead and do a join. So the idea here is to get the user first name, last name, along with their post and their publish date, okay? Because we have users associated with these posts. So I'm going to do select. Let's say select. I'm just going to go on a separate line here. So from the users table, I want the first name. I also want the last name from the users table. And then from posts, I want the title. And let's also get the publish date. Okay, now we want to specify that we're getting it from users, but we want to inner join. I should make this uppercase. So from users, and then I want to inner join the post table. Now it needs to know where to kind of match these two tables, and that's with the foreign key. Okay, or the primary key on the users table to the foreign key on the post table. So we say on users.id, which is the primary key of the users, and then match that against the posts.user_id, which is that foreign key that we created. All right, and then we'll top it off with an order by posts.title. Okay, so hopefully that makes sense. We're choosing these fields from two different tables, or we're saying from the users, but we're also joining in the post table, and we're connecting them by the user ID, and then we're ordering them. So let's run that. And now you can see we get the first name, the last name, and the post of that user, and the publish date. Okay, so that's how you can mix and match related tables. Now I'm going to take it a step further. I'm going to create another table for comments. Now comments are going to have two foreign keys. They're going to have a post ID because they need to be related to a post, and also a user ID because a user left the comment. So let's do create table comments, and let's add an ID of an int auto increment, and we're going to add a post ID, which is going to be an int, a user ID, which will be an int, a body, so a comment body, which will do text, and let's do a publish date here as well. So publish date is going to be date time, and we'll also add a default here of current timestamp. All right, now we need to define our keys. So we have a primary key of ID. We have a foreign key of user. Let's do post ID. And we want to add references to the posts table. And the primary key in the post table is the ID, so we're linking that as a foreign key. All right, and then we want to do foreign key once again, except now we're taking the user ID and let's say references to the users table and the ID field. Okay, so we're now adding two foreign keys onto this in this table. So let's run that. And I'm going to go back to my gist where I have an insert to add some comments. So this right here, add data to comments table. And we're going to run that. Okay, so we'll run that, and then let's do a reload over here, and you'll see we now have a comments table. And if I want to query that table, I can say select all from comments, and there we go. And notice that each comment has a post ID and a user ID. All right, so what I want to do now is get comments and posts, or the comments of a post. So I'm going to do a select. And let's take comments. We want the body from the comments, and then I want the post title. So post.title. And we want to select from comments. And I'm going to do a left join of posts on post.id equals comments.post_id. And then we'll just do an order by, and let's order by the post title. Okay, so if we run that, let's take a look. So we get every comment, and then we get whatever the title of that post that comment is connected to. Now, here's kind of an example of a left join and a right join. So this will give us all the comments that have or all the posts that have a comment. Now, if I were to do a right join, let's just change this left to right and run that. Now, notice we have kind of an issue here. So it's showing every post, even if it doesn't have a comment. All right, and that's, you usually wouldn't want to do that because it's. I mean, why would you? If you're trying to get comments, why would you want empty comments? Because what it's doing is it's taking just all the posts as opposed to, and even if it doesn't have a match, whereas if we did a left join, it would only get posts that had comments that had a match. All right, so I know that's a little confusing, but in this case, you would definitely want to do a left join. Okay, now let's join multiple tables. Let's get the user's first and last name, the comment, and the post title. All right, so I'm going to go ahead and let's say select comments body. We'll just keep that. We'll keep that, but let's also do users dot first name and users dot last name. And we want comments is basically what we're trying to get here, but we're bringing in other tables or joining in other tables. So we're going to do an inner join here of posts on post ID equals comment.post ID, and then I'm going to add another inner join of users on users.id equals comments.user_ID. All right, and that should do it. So let's run that. Looks like we got an error here. I think I forgot. Wait, what did I do? I forgot a comma right here. Let's try that. Okay, so now what we're getting is all the comments. We're getting the title of the post that comment is on, and we're also getting the person that left the comment. Okay, so this is the beauty of relational databases, is having everything in their own isolated table, but we can easily join these tables together, and we can combine the data, and we can make any queries we want based on those relations between the foreign keys and the private keys. All right, so hopefully that some of that clicks. So now we're going to take a look at aggregate functions, which are pretty simple. So if we want to like get the count of a certain, certain field or something like that. So let's clear this up and let's do count. So we'll say select count. Let's count the IDs from users. And this is just an easy way to count how many users we have. So if we run that, we get 5. If we want to check how many posts, we can run that. We have 10 posts. If we want to run it on comments, we have 9 comments. Okay, another thing we can do is max. So let's say we want to get the oldest person. So we'll say select max, and then the field we want, which is age, and then we'll say from users and run that, and the max age is 40. We can also do min. So if we want the youngest person, we could do a min on age and we get 20. We can also do sum. If we wanted to, for some crazy reason, add all the ages together, we get 146. Okay, another thing we can do is uppercase and lowercase. So for instance, we can say select, it's actually U case and L case. So if we want to do U case first name, and then let's do L case for the last name from users. And now you'll see that the first name is all uppercase, the last name is all lowercase. Okay, we can also do group by. So I'm going to go and say select age, and I'm also going to select the count of age. So let's say count age. So basically I want to see how many people are of a certain age. Actually, you know what we'll do? Let me just do a quick select real quick. So all from, you know what, let's not do age. That's kind of stupid. Let's do location, since we have some people are from the same location. So we'll say select location and the count of location from users, and then we want to add on group by location. Okay, so if I run that, what will happen is it gives us one column that has the location name, the distinct locations, and another that has the actual count of how many users are in that location. So this can be very useful. Now we can also add a where clause if we want. So let's say we wanted to get, we'll say where location. Let's say we just wanted to find out how many users live in Massachusetts. We could say from users. I'm trying to figure this out without looking at my notes. So let's say where location is equal to Massachusetts, if I could spell my own state. So if we run that, then we can narrow it down to Massachusetts and see how many users actually are from there. All right, so I think that's pretty much it, guys. We've gone through quite a lot. Everything that I've done is in the gist inside of the description, so don't worry if you forgot everything we just did. It's all there for reference, so if you want to just keep that aside for when you're dealing with SQL. Now, I know that a lot of you guys are web developers, and we didn't really do anything that has to do with programming languages, so I want to just create a quick Node.js app and show you how we can implement MySQL. And I do have a complete video on this with both the standard MySQL driver and something called SQLite, which is an ORM, an object relational mapper, that kind of sits on top of MySQL and allows you to make queries without having to actually do select from and all that. It's much easier. For instance, you could do like, you'd have a user's model, right? This is an actual SQL. This is just pseudocode. So you would have users.find, and that would select all of your users. Or maybe you would pass in one or something like this, ID 1, and that would get the user with the ID of 1. So in a lot of cases, you'll do stuff like that. It's just kind of an abstract over your database, but there are many cases where you would actually put SQL in, especially if you're using PHP, like vanilla PHP with, let's say, PDO. You'll be doing a lot of manual queries like we just learned. So what I want to do is give you just a quick and dirty example of how we can use MySQL and SQL queries within a Node.js application. And of course, you could use PHP, Python, any language at all. But this is just a really quick example using Node Express, which is a web framework, and the MySQL driver. So I'm going to go ahead and just run, and this is just an empty folder called Node MySQL sample. I'm going to run npm init to initialize a package.json, which looks like this. It's just a manifest file. And then I want to install two packages. So I'm going to say npm install, and I want to install Express, which is our framework, so that we can have a route, and also MySQL. So we'll install those two things. Okay, and you can see those got added to our package.json. So now we're just going to create an entry point, so index.js. And in here I'm going to bring in Express, and we want to require Express, and then I'm also going to bring in the MySQL driver that I just installed. So we'll call that MySQL. And then what we need to do is initialize Express. And then we want to listen. We want our app to listen on a port. Let's do 5000. And then we'll just put a arrow function here, and we'll say console log. And let's just say server started. All right, so just that alone will actually run the server if we do node and then index.js. Okay, we get server started. I'm going to cancel it with Control-C, and now I'm going to implement our database. So I'm going to create a variable here called db. Set that to MySQL dot create connection, and that takes in an object with some parameters. We want the host, which is our local host, and we want our user, which my user is Brad, password, so 1 through 6, and also the database that we're using. So Acme. All right, so that's our DB variable, and then we need to connect by calling db.connect. All right, now what I'm going to do is create a route using Express. So we'll say app.get because we're handling a GET request, and let's do /users since we're dealing with the users table. And this takes in a callback with a request and response. And I'm going to create a variable called SQL. So this will be our query. So select all from users. All right, now we can execute this with db.query. So we're taking that db object and calling the query method, passing in SQL, and that's going to give us a callback with a possible error and a result. All right, and then in here I'm just going to say if there's an error, then throw that error. If we want to do throw error. If not, then let's res.send to the browser the result, so the data that we get from that query. And I'll save that. We'll run node index. I know this is really quick and dirty. Server started. Let's go to our browser now, and let's go to HTTP localhost port 5000/users, and there we go. So we're pulling our users from the database. So you can use the same exact queries that we've been using, you can use in here. If we want to just select a couple things like first name, last name, email from users, and then let's do like order by last name. So same exact stuff that we were doing. I just have to restart the server every time we make a change. So if I reload that, now we only get the first name, last name, and email, and they're ordered by the last name. Okay, if we wanted to do joins, we could do that. In fact, I'll copy. Let's grab this right here. So I could literally just take this and put that right in here. Let's see, what did I do? What's wrong here? Select comments body. You know what? I think we have to use backticks here. Yeah. Let's try that. So if I save that and restart the server and go back, and there we go. So we get the comment body, the post title, the first name, and the last name. So you can literally use any of the queries that we were using within here. And you could do that within other languages as well. But as I said, in a lot of cases, you'll use what's called an ORM, an object relational mapper, like Sequelize. How do you spell it? Sequelize. So instead of using the standard MySQL driver for Node.js, you might use Sequelize, where it looks more like, let me give you an example. Let's see. Trying to find a good example here, because you don't write straight queries. So you would initialize a Sequelize instance, and then you could do, Jesus, give me an example. Authenticate, user init. Because you create models, oh, right here. So instead of doing like an insert into user or whatever, something like that, we would create a user model and take that user model and call a method like create, and then pass in the data we want to create, like a first name and last name. All right, so you would do that instead of writing out, you know, a manual insert into query. Now, even though you'll deal with this stuff a lot within many different languages and frameworks and stuff, I think every developer, at least every full stack or backend developer, needs to know the basics of writing, you know, straight up SQL queries. It's just needed. So, you know, even though you might use this stuff, you still want to learn how to write just regular SQL. Okay, so I think that's it, guys. This is a pretty long video, so hopefully you learned something from it, whether you're just getting into SQL or MySQL, or if you've been using it for a while. Hopefully you picked up at least something. So if you did, please leave a like, and I will see you next time.